So in CCNP 2.0, we have a layer 2 technology. In CCNA, we have gone through the basic configuration of PPP. What is a PPP and how does it work? CCNP 2.0, they have mentioned a new topic which is PPPoE, stand for point-to-point protocol over Ethernet. So here we need to configure only client-side configuration, which basically means when you have a DSL connection. Let me explain a little bit more about this, which is coming from your internet service provider. Then it's going to connect with the DSL router. Now you can replace your DSL router. You can directly put your Cisco router right there. In such a way, you need to configure PPPoE client configuration. And the server, the configuration is not part of CCNA or CCNP. This is part of service provider. So we'll shortly going to discuss about PPPoE, but first we are going to take a high level overlook of PPP. So what is a PPP and how does this work? So I have already created a dedicated documents for this, which is this one. You can find it below the video. So the objective of this documents or this session, which we're going to discuss today, PPP configuration and verification, PPP authentication and PPPoE may be part of the next video. So first take a look, a high level overview of PPP. PPP stand for point to point protocol, but I find most of guys they somehow they stuck. So actually, if you're talking about PPP or HDLC, these are the WAN protocol and WAN encapsulation. They are not going to use when you going to connect with internet. So suppose you have a ISP, you may coming internet connection. On that case, you are not going to use actually HDLC or PPP. In case when you have a remote site, maybe across world. So consider this is India, another is US. In such case, we take a dedicated line, which is sometimes also known as a lease line. On this line, we running such kind of encapsulation. So we have couples of options. We can go through frame relay. We can take a share, means we may have a dedicated, which is lease line. We may have a shared, which is frame relay, MPLS or some other. Right. But here we going to discuss about the PPP, which means a lease line encapsulation, we can say. Your PPP can also run top of frame relay. So point-to-point protocol have a many feature over other WAN encapsulation we discuss about. This is media independent, which basically means PPP encapsulation can be run over Ethernet, synchronous asynchronous serial interface, ATM and ISDM. So if your ISP offer you such kind of interface, you can again run such kind of encapsulation. So suppose if you're talking about Ethernet encapsulation, which is only running your fast Ethernet, gigabit or the legacy Ethernet, which is running 10 Mbps. But you cannot use the Ethernet over WAN, sorry, serial interface. But PPP allow you. You can do this. So it is standard protocol, means vendor independent. If you're talking about WAN encapsulation, there is HDLC, which is Cisco proprietary. But if you're talking about PPP, this is vendor independent. It is standard protocol. Any vendor can use such kind of, any vendor can use PPP encapsulation to connect with the remote site. It also supports authentication, compression, and multi-link bundling in reliability. So first let's discuss what is actually authentication. I find most of students they stuck somewhere to understand why we required authentication. Suppose if we using back to back, we connecting back to back router. Suppose this is R1, this is R2. If we running any routing protocol like RIP or any IGP or EGP protocol, we can run authentication over it. So on such case, you actually using authentication on top of your application. But what about layer 2? Layer 2, there is no authentication. Like if you're talking about your switch, in switch we have a port security. It doesn't matter who you are, your MAC address should be matched to the configuration. Similarly, your PPP allow layer 2, you can say, the authentication of link. You should be the right person to connect with that particular link. So this is allowed by PPP. This is not true with HDLC or frame relay if you're talking about. So it can compress the data to send over a WAN. You can also combine multiple links for load balancing, you can say. And they have built-in mechanism for ensure your data is transmitted over destination. So this is reliable as well. If you're using PPPoE, point-to-point protocol over Ethernet, it can also perform fragmentation. We'll discuss shortly what is a fragmentation. Not shortly, we'll discuss on the topic of PPPoE. A fragmentation basically means if any frame which is, suppose this is your router connected with ISP, and most probably your interface going to send data MTU of 1500. But in case of PPPoE going to add some header, which basically means you need to decrease your size of MTU in order to send your data over ISP. So that will discuss on PPP. So let's carry on rest of things. PPP has two sub protocol which is known as LCP and NCP. So these two protocol make PPP work in order to connect with any kind of media, right? So they are going to allow you. PPP also has looped link detection. So what is loop link detection? Suppose if you're going to combine multiple links to make them bundle, so there may be loop can occur. So PPP also going to prevent this loop using the magic number. Okay, so that's good. So now let's discuss what is a LCP and what is the task of LCP and responsibility, you can say in another word. In other word, LCP used for link controlling, authentication. What kind of authentication you using are? It could be PAP, CHAP, MS CHAP, or EAP, which is layer 2 authentication, you can say, or link level authentication. Data compression, bundling multiple link, and error detection. These are tasks of or responsibility of LCP. If you're talking about NCP, Network Control Protocol, they negotiate protocol, what kind of traffic we are agreed to send and receive. Your traffic could be IP, IPv6, your traffic like CDP. So what kind of traffic we going to send between the link, or you can say, so they're going to negotiate your layer 2 and layer 3 traffic, you can say, or traffic type. Are you using IPv4? So your neighbor is agree to send and receive or not? Are you using CDP messages in order to neighbor discovery? So they also going to negotiate these things. They can also assign address. So if you configure, if you're talking about this option PPPoE, your branch router can request to headquarter, or your DSL router can request to the ISP router in order to get a IP address. This can be performed using PPPoE. And they also they also maintain routing information. So suppose if you're using HDLC and you have IP address 1.1.1.1 and 1.1.2.1/24, they're not going to communicate. But if you're talking about PPP, they can send data over it. Actually, they're also going to share their routing information. So suppose this is R1 and this is R2. R1 now going to consider I can get a network which is 1.1.2 over this link. Similarly, R2 going to consider I can get a network which is 1.1.1 over this interface. So this is the advantage you can say of PPP. So the next thing which we're going to verify, the basic configuration and the negotiation. How does negotiation occur? How they going to agree with send and receive traffic, as well as are they going to communicate if they have a different layer 3 networks. So let me turn on my devices, and then after we going to configuration. Now devices up and working. Let me bring my console window so that we can go through the configuration. So in this topology, I am going to use two router, which is branch and headquarter. And I am running router, the series of router, this is 2900. Specifically, if you're talking about the model number, which is 2901, iOS 15.2. So all right, let's go through the basic configuration. So this is my branch router interface S0/0/0. One more thing that I should mention, I think we have discussed on it. So suppose if we going to connect to router like branch in headquarter in wide area network, we have to have a device which is known as CSU/DSU. It could be internal or external. But in case of lab, we connecting these devices back to back using two different cable. So cable is actually DCE cable and another is DTE cable. So they're going to allow us in order to send and receive data. So they actually work as a cross cable. So the sender pins of branch will going to receiver pins of HQ and vice versa. Now the configuration interface S0/0/0, and then I'm going to assign IP address 10.10.10.1, excuse me, 255.255.255.252, no shutdown. So by default, if you're using Cisco router, by default your encapsulation is HDLC. So let's verify the encapsulation and interface type. So controller, if you run command so controller and the name of the interface, you can see that this interface is a data communication equipment. On DCE device, you have to have generate a clock rate, which basically means the frequency which you're going to allow between you and your remote router. The next thing, so interface serial 0/0, interface serial 0/0. Here we can verify the encapsulation is HDLC. So I'm going to hop over HQ on headquarter interface router, sorry. And then after IP address, this is 10.10.10.2, and then subnet mask 255.255.252, no shut. Similarly, here we can verify to run command so controller s0/0/0. So this is DTE, and you can see the clock frequency is detected. So someone is already running the clock rate, and I come to know what is the clock rate. So I'm detected that clock rate, I should say. So now we can say the link is up. So IP interface brief is up and up. Since I have already already executed the command, I should say I have already saved the clock rate. In your case, you may need to run clock rate. Otherwise, by default, the maximum clock rate is already configured. So this is time to check the connectivity between you and your headquarter. As we can see, we do have. Next thing, we need to change the encapsulation of interface. Encapsulation PPP. So suppose if we change encapsulation from branch router, HQ is currently running HDLC. Now, if you run the command show IP interface brief, you will get layer 2 down message, as we can see. And let's verify that. Do show IP interface brief, which is alias I'm using right now. We can see the protocol is down. Status up shows the physical link is up, but data link layer is down because of the encapsulation mismatch. Next thing, I also need to match the encapsulation on headquarter, which is interface s0/0/0, encapsulation PPP. Now your link gonna to up. There we go. Send the packet in order to verify the connectivity. As we can see, we do have a connectivity. But one more thing which I like to show you, debug PPP, and what you want to debug. Authentication, authorization. Right now I'm going to use negotiation. How they going to negotiate what kind of traffic that they are agree to send and receive. So I have turned on the negotiation. What I'm going to do, interface s0/0/0. I would like to set the interface because the negotiation already happened. So now I need to renegotiate and bring the interface, bring back up. No shut. Right. So we can say now, let me view all, undebug the branch one. Now we can see the interface as 0/0 change state to up, and processing something like this. Phase 1 establish using default call direction, session handled by these things, event open request, then magic number which should be same as the destination. So whatever is magic number generated from branch router should be same as a HQ router. Then after they going to agree to make their link up. As well as, so this is task of actually LCP, as we can see. And next we can see the task of NCP. So NCP going to negotiate what we want to send actually. IPv4 packet, CDP, and IPv6 packet if we have, suppose. But in case we can see we sending IPv4 packet as well as CDP. Since we are not using any IPv6 address on it, that's why we're going to negotiate between these two. Sorry, these two these two type of traffic. So now the state is open, which basically means everything is fine. The next thing which I like to show you, they also going to install a route 10.10.10.2. If you run command, so IP route is connected. So this is the route, which is I think this one. Yes. So this is actually route. So let me change the IP address. What I'm going to do, I would like to change the IP address of headquarters. And then after, we going to ensure that are they going to communicate or not if they have a different network. So let me change the IP address of branch as well. Interface S0/0/0. IP address 192.168.1.1, 255.255. Class C IP address, no shutdown. Hop over to HQ router interface serial IP address 192.168.2.2. So right now using 2.2 network, and another router which is branch, they have 1.1. And this is also class C IP address, no shutdown. Let's verify the layer 2 and layer 1 connectivity. So do so IP interface brief, which is alias I have created already. We can see they are not going to affect anymore, or they are not going to affect since your physical and data link layer is everything is fine. The IP address is working on layer 3 as we know. Next thing, let me turn off that interface, which is S0/0/0 shut, and then after, no sir, bring the interface up. Again they're going to negotiate, and now branch going to install a route. So IP route include connected, I think so. As we can see. So on serial interface, I have IP address 192.168.1.1, but I know how to get 192.168.2.2. I can, in order to get this network, I will send data out this interface. Next thing, we need to verify the connectivity. I think it is 2.2. Do so IP interface brief, yes. There we can see yes, we do have a connectivity. So this is, you can say, the advantage of PPP, or the way which PPP use. So no matter what network you using, your PPP is media independent. They also install their route. So which was which was part of NCP. So this is what we can configure in PPP.